Okay, let's start talking about factor trees. Factor tree prime factorization. Okay, so a factor tree would work like this. If we take a number that's composite, is 33 composite? How do you know? If it's composite, if I can find two numbers other than other than 1 times 33 would make it composite. Can you think of two numbers that multiply together to give me 33? 11 times 3. Now we look at those two numbers and we ask ourselves, are they prime or are they composite? 11 and 3. They're both prime. So that is 11 times 3 is the prime factorization of 33. 11 times 3. That's it. Okay, give me another number that you want to try that was hard. 92. Okay, 92. Well, the first thing I notice about 92 is that it's even. So if it's even, if I don't know two numbers that multiply together to give me 92, if it's even, it's divisible by 2. So I could start with taking half of it, right? 2 times, what's half of 92? Well, I know half of 90 is 45 and half of 2 is 1. It's 46. 46. Half of, do you see how I did that in stages? Half of 90 is 45, half of 2 is 1. I add them together, okay? Because it's 90 plus 2, and I did half, 45, oops, plus 1, 46. All right, then I noticed that 46 is even. So, I could actually take half of 46, couldn't I? Any even number, can I divide it by 2? That's the definition of divisibility of 2, right? Half of 46 is 23. And then we look at our chart and we notice, oh, 23 is prime. I can't think of any numbers that I can multiply together to give me 23. So the prime factorization, can anyone tell me how do I write it with an exponent? 23 times 2 to the second power, because I have this is prime, this is prime, this is prime. Okay, the one, let's do another hard one. Oh yeah, a hard on. Yes, roll it back. Okay, because I could write it, yeah, that's how, exactly. Because I could write it like this, 23 times 2 times 2. But what we discovered, like let's say that we did the number 64, okay? 64, that's a pretty big number. It's even, so I could divide it in half. What's half of 64? 2 times 32. Oh, 32 is even, so that's my prime number. 32 is composite. 2 times half of 32 is, half of 30 is 15. Half of 2, yes, 16. She beat me to it. The 2 is prime. Okay, break down the 16. 16 is still even, isn't it? 2 times what gives me 16? 2 times 8. Yeah, 8. The 2 is prime. 8, break down 8. 8 is composite. Two numbers that give me 8. 2 and 4, good. 2 and 4, you see why it looks like a tree, factor tree? Is 4 composite or prime? Composite. Break down 4. 2 times 2. So how many 2's? 1, 2, 3, 4, 5, 6. I could write 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6. I could write it like that, but that just takes up a lot of space. So the exponent makes it simpler, because how would I write it using an exponent? Yes, 2 to the 6th power, exactly right, okay? Any more that you want to go over from the sheet? Prime factorization. If you like this way better, this is totally fine. I mean, there's really no other way. You were just kind of, I didn't teach you a way yet. So let's do it this way on our paper, and then you can write the prime factorization on your sheet. Are there any others that you want to try together? to break them down this way? You get the process? No? Good? You got it? Factor tree. Okay, there it is. Factor tree for the win.